Hello class, welcome to another lesson. Today's learning goals are I can write a ratio in 3 different ways and I can find a unit rate. So you guys have talked about ratios before this year. Ratios are a comparison of two things that are quantities or describe a rate. Okay? So they can be written in 3 different ways. They can be written as words. So for example, 3 to 4. They can be written with a colon, as shown right here. Okay? Or they can also be written as a fraction. All 3 of these right there are the exact same ratio. For every 3 of something, there's 4 of another thing. So, an example of this. In a basket, there are 7 apples and 12 oranges. So we're asked to write this ratio of apples to oranges in 3 different ways. So we have the words way, where we do 7 to 12. There's also the colon way, which is 7 to 12. And then there's also the fraction way, which is 7 over 12. Another way we can do this is to do it with oranges to apples. Now sounds the same, but it's actually different because oranges comes first this time. Okay? So we're going to put our oranges, which is 12, to apples, which is 7. And again, that'd be 12 in terms of colon, 12 to 7. And finally, as a fraction, is 12 to 7. Okay. Here it asks us to do the same thing, except in 3 different ways, write the ratio of apples to pieces of fruit. Even though apples is part of the entire fruit part, we still count the 7 apples when we're talking about this pieces of fruit. So there are a total of 7 plus 12, which is 19 pieces of fruit. So we have 7 apples to 19 pieces of fruit, or 7 to 19, or finally 7 to 19. All 3 different ways. Okay? So when a ratio is used to compare 2 different kinds of quantities, such as miles to gallon, is called a rate. The reason that these are 2 different quantities is because miles is a measure of distance, right? Miles is a measure of distance, while gallons is a measure of how much liquid do you have of something. Okay? So they're 2 different types of quantities. Okay? That's called a rate. Okay? Equal ratios make the same comparison. To find equal ratios, multiply or divide each term of a given ratio by the same number. This is very similar to finding equivalent fractions. Okay? So, again, we can still write these as a fraction, ratios as fractions. So we have 10 and 12, and it says that in order to find equal ratios, we just have to multiply both the top and the bottom by the same number, or divide both the top and bottom by the same number. So let's try multiplying that by 2. We're going to multiply the top and the bottom by 2. We get the equivalent ratio of 20 24ths, excuse me. Okay. So these 2 are equivalent ratios. Okay. We can also divide these. We can divide each one of these by 2. So let's try that out. 10 twelfths divided by 2 divided by 2. We get the equivalent ratio of 5 to 6. Okay. So 10 twelfths and 5 to 6 are equivalent ratios. We don't even need to multiply or divide these by whole numbers, or we don't even need to divide them by numbers that are factors of each one of them. So an example of that would be if we were to divide both of these by, let's say, 3. Okay? So divide both the top and the bottom by 3. We get 10 thirds to 4, or written with a colon, it would be 10 thirds to 4. All of these 1, oops, it should be black. I don't know why it's not turning out black. There you go. This, and these. Okay, 10 to 12, 10 thirds to 4, and 10 thirds to 4 are all equivalent ratios. Now, the simplest form of the ratio 10 to 12 is 5/6, okay, because we like to use whole numbers if possible. We don't always have to, but it's easier if we use whole numbers. And in addition, 5 and 6 have no common factors. Okay, so it's like simplifying a fraction. The simplest form of a ratio is when both of the ratios, or excuse me, both of the terms inside the ratio have no common factors. Okay. So here it says which ratio is equal to 1 and 1/3 to 2. So we need to figure out which ones are similar or equivalent to them. So let's start off by changing the 1 and 1/3 to 4/3 because those are equivalent fractions. Okay, it's easier to see it that way. So when we do this, I like to think about what do I need to multiply or divide a certain number to get one of these numbers over here. So for example, 2 is supposed to be the same thing as 1/2 right there. So what do I have to divide 2 by to get to 1/2? Okay. Well, the answer to that is 2 divided by 4 gets us that. So 2 divided by 4 divided by 4. Okay. And you can use your calculators to do this. And we find out that is 1/3 to 1/2. Okay. Which is not A. A is not the same thing. We have one of the parts the same right here. This 1/2 is the same, but the 2/3 is not the same. So therefore, A is not the correct answer. Okay. Let's try a different one. What about if we did this one? What do I have to do to 2 to get to 6? Well, what I need to do is multiply that by 3. And if I multiply both of these by 3, we get the 6 that we're looking for, but what we get over here is 4. That is the same thing. Okay, so therefore it is going to be B. Our answer is going to be B because when we multiply the 2 by the 3 to get the 6 that is indicated inside the second part of the term, of the ratio, right here, we also get the first part of the ratio as well. So therefore those two are equivalent. Let's try this one out. Which of the following is equivalent to 2.5 to 3? So again, I'm going to change this into an improper fraction right here. So the 2 times 2 is 4 plus 1 is 5 halves to 3. Okay. The question becomes, what do I have to multiply this 3 by to get 5? And the answer to that, as we know, is we need to multiply it by 5/3 because the 3's cancel out from each other and we get 5 at the top. And we're going to have to multiply this one by 5/3 as well. Okay. When we do that, what we find is we get the 25 over 6 to 5. And 25/6 is not the same thing as 3.5. In fact, that is 4 1/6. Okay. So therefore, A is not one of our options, not the correct option. So let's try B. What do we have to multiply 3 to get to 4? The answer to that is we're going to multiply that by 4/3. That means we're going to multiply the second term by 4/3 as well. When we get that, we get 4 over here and 20 over 6. And 20 over 6 is not the same thing as 3, so B is not our option as well. Let's try C. Again, what do we have to multiply the 3 by to get 10. The answer to that is multiply it by 10 over 3, so the 3's cancel out. We get 10 left over times 10 thirds. And what we end up getting is 10 over here and 50 over 6 over here. And when we simplify that, that's the 25 over 3. And when we simplify that, we find that that is, in fact, 3 goes into 25 8 times, and we get 8 1/3. So therefore, our option C is the equivalent fraction. Okay. So let's talk about unit rates. Okay. The unit price of an item is the price per unit of measure. Okay? The unit could be ounce, quart, pound, or some other unit. To find the unit price of an item, set up the following proportion and solve. So the price paid divided by the quantity bought in units equals the unit price over 1 unit. Okay? But since the denominator of the second ratio is 1, as we can see, oops, not there, but right here, 1, okay, anything divided by 1 is just itself. So therefore, the actual equation is price paid over quantity is the unit price. Okay. So let's try to figure this out. Kyle made $88.65 in 4.5 hours of work. What is Kyle's rate of pay? What we would simply do is create the ratio 88.65 to 4.5 and divide that. Okay. And when we do that in our calculators, we should get 19.7, which means he gets $19.70 per hour. Okay. Make sure you're using units in here because this is $88.65 and this is hours. Remember, the word per means divide. Okay. Per means divide, which is what we used right here. Remember that fractions are division. $19.70 per hour, and our answer is correct. Here, this is not a price, but this still talks about rate. Okay, Savannah ran 1.5 of a kilometer in 1/3 of an hour. What was her rate in kilometers per hour? So she ran 1.5 kilometers in 1/3 of an hour. So we're looking for kilometers per hour. Again, remember that per means divide. So we're going to take the amount of kilometers that she ran, which was 1.5 right here, and divide it by the hours, because it says per hour, okay, which was 1/3 of an hour. So we're going to do is 1.5, which is 3 over 2, divided by 1/3. Okay. This is kilometers per hour. Okay. So in order to do division with fractions, we do keep, change, flip, which means 3/2 times 3 over 1. This gets us 9 over 2, which is the same thing as 4.5 kilometers per hour. Okay, which is correct, 4.5 or 4.5 kilometers per hour. Okay. And you can do this all on your calculator if you'd like. A 64-ounce bottle of Sprite costs $1.99. What is the unit price in dollars per ounce? Okay. Again, we have dollars per ounce right there. So therefore, we're going to take this amount, the dollars, okay, and divide by the number of ounces. okay, because it says dollars per ounce. So therefore, we're going to do $1.99 divided, because per, 64. You can do that in your calculators. And when you do that, you get 0.031, which we're going to round to 3 cents because we can't have 0.1 of a cent. Okay, so 3 cents per ounce, okay, which, according to this, is the correct answer. The final question we're going to address is this one. Which one is the best buy? Okay, 6 cookies for $5, 10 cookies for $9, 12 cookies for $10.50, 90 cookies for $85. So which one gets us our best value? In order to do this, we need to find the ratio of the cost to cookies so that we find out how much each cookie costs. Okay, dollars per cookie. So dollars per cookie, which means that we're going to have to find the rate for each one of these, which means that we're going to have to do $5 divided by 6 cookies. Okay, and we want to have each cookie cost the least amount. Which one of these gives us the lowest price for each cookie? We get 5 divided by 6. We find this is approximately, when rounded, 83 cents per cookie. Okay. For question B, it's 10 cookies for $9. So we get $9 divided by 10 cookies, which is 90 cents for each one. So that's not going to be the correct one. Oops. That's not what we want. There we go. That's not going to be the correct one either. So 90 cents is not correct. So let's just erase that one because we know that one's wrong. Let's try C. What we get is $10.50 divided by 12 cookies. And what we find that to be is, when rounded, 88 cents per cookie, which again is not better than the 83 cents per cookie. We want the cheaper one, so we're going to just erase that one because we know that one's not the right one. The last one we need to try is 90 cookies for $85. Again, we're going to do dollars per cookie. So $85 divided by 90 cookies. What we find that to be, when rounded, is 94 cents. Okay, so therefore our best option is A, okay, because we get that at the lowest price per cookie.